The statement that any load center more than 6 feet away from the meter must be subfed is not entirely accurate. The requirement to subfeed a load center located more than 6 feet from the meter is dependent on specific factors, including the type of load center, its accessibility, and its location. In some cases, especially with load centers that are not readily accessible or are situated in hazardous locations, subfeeding is necessary to ensure safety and compliance with electrical codes. However, in a residential dwelling, if the load centers are located within the same dwelling unit and are readily accessible, they can often be fed directly from the meter without the need for subfeeding. Accessibility is a critical factor. A load center is considered readily accessible if it can be reached quickly without the need for tools, ladders, or the removal of obstacles. This ensures that the load center can be easily accessed for maintenance, repairs, or in case of an emergency. The location of the load center is also important. If the load center is located in a hazardous location, such as an area with explosive or flammable materials, subfeeding may be required to provide an additional layer of protection. In the specific scenario where a house is separated into two services at a duplex meter base, with one 60 amps fuse panel located in the attic and another in the garage, the requirement to subfeed either of the load centers depends on their accessibility and location within the same dwelling unit. If both the attic and garage load centers are readily accessible and within the same dwelling unit, there is generally no requirement to subfeed them. They can be fed directly from the meter base. However, it is always recommended to consult with a qualified electrician and to refer to the latest edition of the National Electrical Code or NEC and any local electrical codes to ensure compliance. The NEC provides detailed guidelines on the installation and wiring of electrical systems, including requirements for subfeeding load centers. Here are some key considerations to keep in mind. Firstly, accessibility. Ensure that the load centers are readily accessible for maintenance, repairs, and emergencies. Secondly, location. Determine if the load centers are located in hazardous locations that may require additional protection. Thirdly, electrical codes. Consult the NEC and local electrical codes to ensure compliance with all applicable requirements. Fourthly, qualified electricians. Seek the advice of a qualified electrician for guidance on the specific requirements for your installation. Subfeeding a load center involves feeding it from another load center or panel board, rather than directly from the meter. This can be done for a variety of reasons, including to provide additional overcurrent protection to isolate circuits, or to reduce the voltage drop in long runs of wire. When subfeeding a load center, it is important to ensure that the feeder conductors are properly sized to carry the load and that the overcurrent protection devices are properly coordinated. The size of the feeder conductors must be adequate to handle the total load connected to the subfed load center. This is typically determined by calculating the total amperage of all the circuits served by the load center and then selecting conductors with an ampacity rating that meets or exceeds the value. The NEC provides tables and guidelines for determining the appropriate conductor size based on the ampacity and the type of insulation. Overcurrent protection devices, such as circuit breakers or fuses, are essential for protecting the feeder conductors and the equipment connected to the load center from overloads and short circuits. The overcurrent protection devices must be properly sized and coordinated to ensure that they trip before the conductors or equipment are damaged. The NEC also provides guidelines for selecting and coordinating overcurrent protection devices. In addition to these technical considerations, it is also important to follow all applicable electrical codes and regulations when installing and wiring a load center. This includes requirements for grounding, bonding, and wiring methods. Grounding is the process of connecting the electrical system to the earth to provide a path for fault current to flow back to the source. This helps to protect people from electric shock and to prevent damage to equipment. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that the overcurrent protection device is tripped quickly in the event of a fault. Wiring methods refer to the way that electrical conductors are installed and protected. The NEC specifies a variety of acceptable wiring methods depending on the application and the environment. Examples of wiring methods include conduit, cable, and wireways. When working with electrical systems, it is important to always take safety precautions to protect yourself from electric shock. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing circuits before working on them. It is also important to be aware of the potential hazards of electricity and to follow safe work practices. In summary, the decision of whether to directly feed or subfeed a load center depends on several factors, including accessibility at location and electrical code requirements. In many residential applications, direct feeding is permissible if the load centers are readily accessible and within the same dwelling unit. However, it is always recommended to consult with a qualified electrician and to refer to the latest edition of the NEC and local electrical codes to ensure compliance and safety. By following these guidelines, you can ensure that your electrical system is installed and wired correctly and safely. Always remember that electrical work can be dangerous, and it is best to leave it to qualified professionals if you are not comfortable or experienced.